Imagine a world where the sky isn't just a canvas of clouds, but a vast, invisible machine working to cool our planet. In the air we breathe, carbon dioxide is building up like a silent storm, warming the earth in ways we can't always see. Carbon capture isn't just science fiction. It's a real, tangible technology that might help us cool the climate. This isn't just about slowing climate change. It's about giving us a chance to reverse it. Today, we're diving into the strange, powerful, and maybe even revolutionary world of carbon capture. Carbon capture is the process of trapping carbon dioxide emissions before they enter the atmosphere. It's like a giant high-tech sponge that absorbs excess CO2 from power plants, factories, or even the air itself. Once captured, the CO2 is compressed and transported to storage sites, often deep underground in old oil and gas fields or saline aquifers where it can remain trapped for centuries. These systems use chemical reactions, often involving amine solvents or solid sorbents, to bind CO2 molecules and separate them from the air or exhaust. The goal is not just to capture CO2, but to store it safely and securely, ensuring that it doesn't return to the atmosphere and contribute to global warming. While the science is promising, the scale and cost of deployment remain major challenges. But for a world still reliant on fossil fuels, carbon capture offers a crucial bridge to a cleaner future. Carbon capture isn't just a tech buzzword. It's a key player in the fight against climate change. If we don't act, the consequences will be felt by everyone, not just scientists or policymakers. Imagine a world where your daily commute, your home, and even your food choices contribute to a warming planet. That's the reality we're facing if we don't invest in solutions like carbon capture. The stakes are high, and the time to act is now. Carbon capture is more than just a technical fix. It's a chance to reshape our future, one that's less polluted, more sustainable, and more livable. Your life, your health, and your children's future depend on the choices we make today. Carbon capture is a way to ensure that the planet we inherit is still habitable. You might not be a scientist, but you're part of the solution. Supporting carbon capture means investing in a cleaner, more stable world for all of us. Back in the 1970s, carbon capture was first proposed as a way to trap CO2 from power plants, a radical idea that seemed far-fetched at the time. The concept is simple: capture the emissions before they entered the atmosphere. But the technology was complex and expensive to implement. By the early 2000s, governments began investing in pilot projects, hoping to scale up the technology and make it economically feasible. Today, we've seen some early successes, but the path to widespread deployment remains challenging and uncertain. The history of carbon capture is a story of ambition, setbacks, and the persistent hope that this technology can be part of the climate solution. Imagine the air you breathe is a big bag of invisible bubbles. Some bubbles are called CO2, and they trap heat in the atmosphere. If we could catch those bubbles before they escape, we could stop the planet from getting too hot. Carbon capture is like a superhero suit for the atmosphere. It catches the CO2 bubbles before they get into the sky and helps cool the planet by keeping them out of the air. It's not magic, it's science. We use special machines and plants that pull CO2 out of the air or from smokestacks, like catching raindrops before they fall. Once caught, the CO2 can be stored underground or used for something else, like making concrete or fuel, so it doesn't return to the atmosphere. Carbon capture is one tool in the toolbox. It's not a magic wand, but it can help slow down the warming of our planet if we use it wisely and with care. The first step in carbon capture is setting up the right infrastructure: power plants, industrial facilities, or even direct air capture units. These sites are where the carbon is emitted and where the capture process begins. These facilities are often equipped with advanced systems that can extract carbon from flue gases or the atmosphere. The location is key because it allows for immediate capture before the carbon enters the atmosphere. Sometimes the carbon is captured directly from the air using specialized machines that mimic natural processes. This is especially important in places where emissions are harder to control. The capture technology varies. Some use chemical absorption, Others rely on physical adsorption. The setup is tailored to the source of the carbon and the scale of the operation. This setup is the foundation of the entire carbon capture process. It determines how much carbon can be captured, how efficiently, and ultimately how much we can reduce our climate impact. Once CO2 is captured, it must be transported to a storage site. This is typically done via pipelines, which move the gas under high pressure through underground networks. These pipelines are engineered to safely carry large volumes of CO2 over long distances, often crossing multiple regions and connecting to storage facilities. Upon arrival at the storage site, the CO2 is injected into deep geological formations, such as depleted oil and gas fields or saline aquifers. These formations are carefully selected to ensure the CO2 remains trapped for thousands of years, preventing it from re-entering the atmosphere. Monitoring systems continuously track the stored CO2 to confirm it remains securely contained and does not migrate upward or leak out. The clever twist comes when the captured carbon is no longer just stored. It's transformed into something useful. This is where the technology steps beyond mere containment and into the realm of value creation. By using high-temperature heat and a catalyst, the carbon is chemically converted into solid minerals like limestone or even synthetic fuels. This isn't just storage. It's a reimagining of carbon's role in our energy system. By turning carbon into something valuable, the technology avoids the limitations of traditional storage. It also helps to create a circular economy, where carbon is not just removed, but repurposed. This clever twist means that carbon capture isn't just about mitigating climate change. It's about rethinking how we use carbon itself, making the process both sustainable and profitable. At the heart of carbon capture is a process known as direct air capture, which pulls carbon dioxide from the atmosphere using chemical reactions that mimic the natural cycle of plants. Once captured, the CO2 is compressed into a dense liquid and transported to a storage site, often deep underground in geological formations that have locked carbon away for millennia. The process requires energy, usually from renewable sources, to minimize its own carbon footprint and ensure it's a net negative emissions solution. Scientific models suggest that if deployed at scale, carbon capture could neutralize up to 10 gigatons of CO2 annually by mid-century, significantly slowing global warming. Yet, the science is still evolving. Researchers are refining materials, improving efficiency, and exploring ways to make the process more sustainable and economically viable. The science is complex, but the goal is clear: to create a bridge between what we've emitted and what we can still prevent. Imagine a sponge that never dries, constantly soaking up the water from the air, then squeezing it out into a giant, invisible reservoir. This sponge is Earth, and the water is the carbon dioxide we've emitted into the atmosphere. This is carbon capture, the process of trapping atmospheric CO2 and locking it away, like a sponge holding water in a dry desert. It's a simple, intuitive image that captures the complexity of a process that could be our most powerful tool in fighting climate change. Not perfect, not elegant, but it gets the job done. And that's what we need. A metaphor that's both simple and scientifically sound. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.